What's up guys, what's up girls? In this video we'll look at what pattern matching is and how to implement it. Before we get started, if you like my content, please subscribe and like the video. In addition, I invite you to watch the previous video, which I'll include as a description of this video. So to start with, we are going to disassemble the program we made in the previous video using GDB, but before let me run the program. Okay. And now pydof-s my game to have the PID sudo gdb-p the PID. Okay, so we disassemble the main function, and as you can see at this address we call a function called display value. So let's disassemble this function too and see what happens. Disassemble display value. Okay. For example, here we have this, okay, at this address, and we want to get this address every time without resorting to offsets. What's more, if you're not comfortable with the basics of assembler, don't hesitate to let me know. If many of you ask, I'll make a series of videos on the subject. Okay, let's continue. Now we'll disassemble our program via objdump, so cdf game. To do this, we write objdump dash d dash g dash m intel my game t.txt. Okay, so here we disassemble the entire program using Intel syntax and save the output in a t.txt file. So let's open the file and go to the display value function we found via GDB earlier. As you can see, it's pretty much what we had with GDB, but here we also have the hexadecimal translation of this assembly code. Okay, and as you can see, we have RIP plus 0xe7a, and 0xe7a is an offset, so if we update the program it's likely that this offset will change. So the aim of the pattern matching is to keep what doesn't change, in this case 48AD05, and to replace what may change, in our case 7A 0E0000 with question marks or the like. However, this pattern may be present in other parts of the memory and may not be unique. To do this, we need to add information by adding, for example, the following hexadecimal code. Note that the question marks will be what we call wildcards. Okay. So let's coding and go to our main file. Oops, nice. So define this, include stdu.h, include stdlib, string.h, unistd.h, and fcntl.h, and the process.h. And here I'm going to define max pattern length, yeah. Okay, so first we'll write a function to convert the byte pattern into an array of bytes and generates the associated mask. This function is essential for our search for patterns in memory. So let's write void pattern to bytes and mask const char pattern inside char bytes inside char mask mask bytes and size t length size t pattern len, and let's write strlen pattern divided by 2. Okay, so first we calculate the length of the template by dividing the length of the string by 2, as each byte is represented by 2 hexadecimal characters. Now bytes equal inside char and malloc pattern len. Here we have mask bytes equal inside inside char malloc pattern len, and the length equal pattern len. Nice. So here we allocate memory for the byte and mask arrays. We also store the model length. Char bytes str equal 0. So this line is to store each byte as a string, and for size t I equal 0. Pattern len I plus str ncp I y. Okay, bytes str so okay, this line copies 2 pattern characters from position I multiplied by 2 into byte underscore str. This gives us a temporary representation of the hexadecimal bytes. We declare a small string byte underscore str to store each byte temporarily. Sorry for the pronunciation. And next we copy 2 characters from the pattern string into byte underscore str. Size 3 is chosen to include the 2 hexadecimal characters plus the null character at the end of the string. Okay, let's continue. str compare. Yep. Byte str double question marks equal 0. So bytes I equal 0 and mask bytes I equal 0, else bytes I equal inside char str yep, str tool byte str null, yep, and here mask bytes I equal 0xff. So okay, here's what we do. if a byte underscore str contain double question marks, this means it's a wildcard byte, so we put 0 in the byte and mask arrays. Otherwise, we convert byte underscore str to an hexadecimal integer and store it in the byte array and put 0xff in the mask array. And here printf debug pattern and mask converted to bytes. Good. So next we need a function to check whether a pattern matches a given memory region. This is where we'll use mask to in your wildcard bytes. So int mask check const inside char memory const inside char pattern const inside so pattern const inside char mask size t pattern and size t offset. So this function takes as an input a pointer to a memory region, a byte pattern, a mask, a pattern length, and an offset in memory. Okay, so for underscore t I equals 0, I okay I plus plus if memory memory offset plus I and mask I is not equal to this. Yep, okay. Return 0. So we go through each byte in the template and compare matching bytes in memory using mask to in your wildcard bytes. If a byte doesn't match, we return 0. And here return 1. If all bytes match, yeah, we return 1. Okay. In addition, we need a function to scan a region of memory for a specific pattern. This function will read the region of memory, then use mask check, so the previous function, to see if the pattern matches. So unsigned long find pattern in memory region. So const process proc inside long start inside long end const inside char pattern const inside char mask and size t pattern len. Okay, good. So size t size equal end minus start. Inside char buffer equal inside char malloc size if we didn't have buffer, mirror failed to allocate memory, and here return 0. So we calculate the size of the memory region to be scanned and allocate a buffer to read this memory. If allocation fails, we display an error message and return 0. So over here, printf debug reading memory from 0x% lx to 0x% lx start end. So if rpm nice proc start buffer size is not equal to size, let's freeze the buffer and return 0. So here so we read the memory of the specified region into the buffer. If the read fails, we freeze the buffer and return 0. Now for size di equals 0, I size minus pattern size minus pattern len I plus plus. If mask check buffer pattern mask pattern len I printf debug pattern matched at offset persons ZU in region 0x% lx to 0x% lx \n I start end. Okay, so free buffer and return start plus I. Okay, so we scan the memory buffer and use mask check to check if the template matches. If a match is found, we display a debug message and return the address of the match. And if no match is found, we release the buffer and return 0. So free buffer, return 0. Okay. We're going to create a function to list all memory region with r-xp permissions. So read, execute, and non-modifiable. This will let us know which memory regions to scan. So void list list all rxp regions pad t pad list all rxp region. Okay, so show maps path sn print f maps path size of maps path /proc /%d maps npad. Now file maps file equal f open maps path in read mode. If we didn't have maps file error fail to open maps file. Yeah, okay, and we just return. Okay, so here it's not complete. So here it's not difficult. We open /proc /pad /maps file to read the process's memory regions. If opening fails, we display an error message and returns no shoreline while f gets line size of line maps file inside long start end. Okay, char perms if ss can f line percent lx percent for s, yeah, start and perms is a different tree. Here we continue, and here if str compare perms dash xp is not equal to 0, we continue, and here printf debug found r-xp region from 0x% lx to 0x% lx \n start end. Okay, so we read each line of the file and extract the start and the end addresses, as well as the permissions. If the permissions are not dash xp, we ignore this line. Otherwise, we display the addresses of the r-xp memory region. And now just fc close maps file. We'll create a function to scan all the r-xp memory regions of a process for a specific pattern. So void find pattern in all memory regions, find in all memory regions. Yeah, okay, sorry. So const process proc constant signs char pattern constant signs char mask size t pattern len. Yeah, okay. So char map pass def maps pass maps pass, yeah, size of maps pass slash proc slash %d slash maps process get pid proc. Okay, so file maps file equal f open maps pass in read mode. Yep, if we didn't have maps file error fail to open maps file and return up char line while f gets line size of line maps file inside long start end plus 5 if sscanf, we have the line %lx %lx for s start and terms different tree. Yep, continue. If str compare perms r-xp not equal to 0, we continue. Nice. So printf debug scanning region from 0x% lx to 0x% lx with permissions %s \n start and perms. Inside long found address equals find pattern in memory region proc start and pattern mask pattern len. If found address is not equal to 0, let printf pattern found at address 0x% lx found address, else printf pattern not found in region 0x% lx to 0x% lx okay, and fc close maps file. Okay. Okay. So I think all is good now. So let's write the main function int main in rgc v if rgc is not equal to 2 fprintf your usage process name rgv 0. Okay, and return exit failure. Nice. So now we create a process object for the target process. If creation fails, we display an error message and terminate the program. So process proc equal process create. If we didn't have proc, fprintf r fail to create process object for %s \n return exit failure. So now printf process name %s pid %d process get name proc and process get pid proc. Nice. So now file pattern file equal fopen. Let me write pattern.txt. Okay, in read mode. So if we didn't have pattern file, pure fail to open pattern file and process destroy proc and return exit failure. Oops. Okay, so char pattern str max pattern length equal 0, fscanf pattern file pattern %s and pattern _str fc close pattern file. So we check that the model is not empty. If it is, we display an error message, destroy the process object and end the program. If str len pattern str equal 0, fprintf str pattern is empty. Please provide a valid pattern. Process destroy proc and return exit failure. Now inside char pattern equal null, mask equal null, size t pattern len pattern to byte and mask pattern str pattern mask pattern len. So we convert the model into byte arrays and generate the mask using the function pattern to bytes and mask function. And now list all so process get pid proc, find pattern in all memory regions, proc pattern mask pattern len, and now free pattern free mask process destroy proc and return exit success. Okay. So let's compile. Okay. So now I think all is good. Yep. So now we are going to create our file pattern.txt, and if we go in the game vm.txt, we search the display value function. So here let's write, oops, so I'm going to copy this and paste this. So here we put this, okay, and now we put this too, okay. So let's run the program. Oops, my game. So let's write pattern. So now let's run our program, and as you can see, he found this address. So if we do this and we disassemble the display value function, so as you can see, we have here the same address. Okay, so now let me change or update my game. Okay, so here I'm going to write foo printf nothing to do. Okay, and gcc fgame my game. Let's run it. Okay, and now let's do the same what we made before, and let's write vm t.txt do to our display value function, and now as you can see this offset change. So if I go here and write vm pattern.txt, let me delete this and copy this. So this is didn't change, but here let me add double question marks. Okay, and add this. Now if I run this, he found this address. Okay, so let me do sudo ggb -p 174 258 9, sorry. Disassemble main. Okay, so here we have the display value function. So disassemble display value, and if I put the address we found is different of this, so let's disassemble this function. Okay, so this function, if we disassemble this address, sorry, we found the function foo. So why? If we go to our foo function, this hexadecimal code is the same here. Okay, so we need to add information, maybe this line. Okay, so let me get GDB and go to our pattern file, add this information, and now run. So this address is different now. Disassemble display value, and here we go, we found the good address. In conclusion, when you want to obtain the right addresses via pattern matching, it's best to add information in case an update distorts your pattern matching. Okay, so this is the end of this video. See you next time. Bye.